Hello, everyone. Mr. Schultz here as we dive into the idea of multiplying polynomials. Our learning objective for today is to be able to multiply two or more polynomials. So the distributive property reigns supreme when we want to when we want to multiply groups of numbers or variables. Just remember, we're using the distributive property. A fancy version. For example, we have two ways we normally do it. We have the FOIL and the area model. So the FOIL, or the claw, we're going to multiply the first ones. So 2x times x. The outsides, 2x times 3. The insides, 4 times x. And then the lasts, 4 times 3, negative 3. And this kind of looks like a claw, like a lobster claw. So I call it the claw. But just remember, might not be the best for you. So if I actually get this, I get 2x squared. I have plus 6x. This is 4x plus 4x. And this 4 times negative 3 is minus 12. And then I combine these things. The outsides don't have to combine anything, but the insides do for some reason. 10x minus 12. Now let's show you the area model way. Basically, we just take everything and we give it its own little box. Some people like to call it the Punnett square. Some people like to call it the multiplication grid. I like to call it the area model. And so we just multiply and then add it. So negative 2x times 3x is negative 6x squared. And negative 2 times negative 5 will give me a positive, but it has an x, so don't forget it. And negative 5 times negative 4 is positive 20. And negative 4 times 3x is negative 12x. And then the only thing we really need to combine is this middle part right here. And 10x minus 12x would be minus 2x. I have this plus 20, and I have this minus 6x squared right there. I like to use the area model because it's faster and it's more conceptually based. Like you can grasp it, you can see it. So it doesn't matter which one you prefer. There's no we're not going to judge you, but we are. Because you should be able to critique. So critique the reasoning of someone when they use one way or the other way. So if somebody makes a mistake, you could look at it and be like, oh, you skipped a step. Or you could look at another one and be like, hey, why did you do that? And if you don't understand what they're doing, go ahead and stop them and ask them. Be like, hey, can you explain that one part? I don't get it. So let's multiply these polynomials. I'm going to use the area model. You can use this, or you can use the FOIL method. So I just create. If I only have it by itself, then I don't really have a lot. That's going to be, let's erase that part. Let's erase that. I want to make it bigger. So 3p times np would be 3np squared. And this 3p times negative z would be negative 3 zp. Just remember, don't multiply things. You can just put them together. It doesn't change anything. It's still z. What's z times p? Hey, it's z times p. What's n times p squared? It's n times p squared. We don't really have an idea what it is now, but if we got what those variables were equal to, then we could figure it out later. All right, let's multiply this one. I'm going to set it up, and I want you. So if I took this out, it would look like this. There we go. Done. So now let's set up our area model. I have two terms, so I'm going to have two boxes. One term on the outside, two terms on the inside. And now I just need to multiply. So I'm going to multiply the numbers. So I have negative 8, and x times x is x squared, and I have a y. And 4xy times 4 will be, hey, what's 4 bananas times 4? It's 16 bananas. So what's 4xy times 4? It's 16xy. And then I just combine them. I'm going to have this negative 8x squared y plus 16xy. So here we go. We're going to get into some of the nitty gritty right now. We have this a minus 5, and it's squared. Well, what does that mean? I have it twice. I have this a minus 5 twice. So what I'm going to do is I'm going to just multiply it to itself. Minus 5a, and negative 5 times negative 5 is 25. And now I just need to combine them. So while these stay the same, but the middle part changes. Minus 5y is minus 10a, not y, sorry. So let's go ahead. I want you to solve the next one. I'll show you my work in 5, 4, 3, 2, 1. All right, here it comes. So here's my area model right here. And if I combine everything inside, I should get the following. All right, there we go. So now we're going to continue, and I'm going to give you a little more time to check your understanding. See if you're understanding it, okay? Now, if you don't get it, it's okay. We'll work on it. Go ahead and try these two by yourself, and then I'll show you the answer to each one separately. Let's do the first one in 3, 2, 1. So you can tell right here that the middle cancels each other out because they're adding the opposites right here. We have this minus 2t plus 2t. That creates this plus 2tr minus 2tr. Now we'd use this in our last section. All right, now let's do the next one. So our final result, there's our new polynomial. So now, try the next one in 3, 2, 1. All right, so there's our trinomial right there. It's our trinomial because we have 3 monomials. Okay, now we're going to level up. What if we have something with more than 2 binomials? So what if we're multiplying this? Well, my hint to you is, hey, do it one at a time. So let's do the first one. We have 3x plus 5, and we have a minus 7. Now, I could ask you, hey, what's 2 times 3 times 4? And wait for your answer as you're like thinking about it. Or I could say, hey, what's 2 times 3? And then ask you, times 4 now. You'll get the same answer. So I'm going to multiply this and do it twice. So I have 3xa, a times 5 is 5a, 3x times negative 7 is negative 21x, and negative 7 times 5 is negative 35. So if I combine these, I have 3xa plus 5a minus 21x minus 35. So that's what we get when we multiply these two. And now I still need to multiply 4a plus 1. So just do it again. So I have 4 of these right here. So now I'm just going to create 4 boxes across and do it again. So I'm going to write 3xa, and I'm going to pause it and put my work. So here's my area model. So 1 times anything is going to be nice. So it's literally just whatever's on the bottom or whatever I'm multiplying. There we go. And then I have this minus 35. Now the 4 is going to be kind of tough. 4a is going to be 12, 4 times 3. And then I have the x, and then I have the a squared. 4a times 5a is going to be 20a squared. 4a times negative 21x will be negative 84xa. And then 4a times negative 35, well, 2 times 35 is 70. If I times it by again, I would get 140. So this is going to be negative 140a. Oop, negative 140a. And so now I just go through and I see, what do I have? Okay, I have this negative 35 right here. And I can make a little cross. I'm like, all right, I'm done with this guy. There's no other numbers that are by themselves. Okay, are there any x's by themselves? No, this is it. There's only one. So I'm right, minus 21x. I'm going to put a little x right there. I have 1a. Now look, not xa. I want a. Any a's? A squared? No, I want a. A. Oh, right here. Negative 140a. Well, then this would be negative 135a. All right, so we write that and we put it right here. We cross off and cross off. Now I have an xa. Are there any other xa's? Not xa squared, xa. Well, right here. So negative 84 plus 3 would be negative 81xa. There's no other xa's, so we're done. We'll put a little cross. Now the reason why I cross it, what I've been told in the past is, hey, just cross it out. But if we do that, then what if we made a mistake? We want to be able to see it and be like, oh, I made my mistake right here. All right, these are the last two right here, xa squared and a squared. They're the only monomials we can't combine, so we just write them out. So I have 12xa squared plus 20a squared. So here, right here, this guy right here will be our largest type of problem. So if you're like, oh my goodness, this would probably be the conclusion to one of our quizzes. It's so big. Don't worry too much. This is a little more than necessary. All right, let's go on. So we really only have these last two. So why don't you try to do it, and I'll show you my work in just a second. In 3, 2, 1. The first one, try it now. All right, there's our first polynomial right here. You can see that we combined like terms, and then we simplified. There we go. Try this next one. It's going to be a little more complicated. In 3, 2, 1. So what makes this more and more complicated? Well, we're multiplying the same variables. And so we are able to combine different rows. But when we multiply, bringing in new variables, you'll notice that we can't combine any of these because they all have different terms in them. We have a squared x, abx. There's no other abx's here. So all of these are going to be standalone, and we just add them in row. We would just rewrite it. Put 4a squared x plus 10abx plus 6b squared x minus 2a squared y minus 5aby minus 3b squared y. They share no common variables. So they are not the same term, so we can't combine them. That's it. All right, guys. You have a wonderful day, and I'll see you in class. Bye.